Ted D'Elia. Ted has spent most of his working life designing tyres. Ted has an in-depth knowledge of tyre technology and its evolution. Ted describes the tyre design from cross-ply to radials, giving some handy hints along the way. Welcome to another episode from the Macedon Rangers and District Motor Club.
Cross-ply tyre that's been there since John Dunlop basically developed the vulcanization process, and that's how tyres were made for, like started in the business in 1974. We were still making them in 1989. There's no one that manufactures them anymore in Australia, but they're still very big in the Asia Pacific region. India being a point in case where most of the tyres, passenger or otherwise, are still cross-ply. So the cross-ply tyre is when John Dunlop will start making them, were basically made of cotton, and that's where the term ply rating comes from. So if you bought a 4-ply tyre, you actually bought a tyre that had 4 actual pieces of material in them that were made of cotton, covered with rubber, and that gave it the strength it needed to retain air. So you can see what happens there. You got the construction is very simple. You have 4 plies, and they are crossing each other at quite a sharp angle. You know, if I remember my design specification was anything between 55 degrees and 75 degrees, depending on the tire that you're making. Before you did that, you still had an inner liner. Now, up to about 1980, the inner liner was still there. It was a butyl inner liner, but it didn't hold air properly. That's why we had to put tubes on it. And up to 1990, the police, even though they were using radial tires, still insisted of having tubes inside their tires, but they didn't trust the tubeless tire. And I had to actually prove it to them that by having a tube inside the radial tire, it's actually more dangerous. Because you put a puncture on it, you're going to get an immediate deflation of the tire. Well, with a cross-ply tire, well, at least the inner liner held some strength. You know. There's an apex strip that was all hand applied, so therefore you had all sorts of issues with air, bubbles. The bead wires were all, again, hand applied. The thread and the sidewall were one piece, so getting an accurate uniform tire was very difficult. The complete tire was built on a very flat drum, so there was no pre-inflation before it got into the mold. There was none of that good stuff, and yeah, so they were tough, but they were not the greatest tire in the world. However, cars like the Corvette came out on cross-ply tires. Most American cars, even high-performance American cars, did originally come out with cross-ply tires. The problem is now, of course, those are not available anymore. So what do? You buy radials. Be very careful when you buy radials, because you got 2 tires that are so dramatically different. It's not funny. About 1980. I was working for Olympic Tyres, then we started playing with what we called a bias-ply tyre. We started cutting up a few tyres from the opposition, and we started seeing the radial tyre coming into the Australian market. Olympic didn't have that much money at the time to spend on development, so we did all our own. So the only way we could learn what other people were doing is actually buying tyres and cutting them up, which was one of the jobs I did, buffing and carrying on and doing all sorts of things. And we developed what's called a bias belted tyre. So the same construction as a radial, as a cross-ply, very sharp angles, the same type of thread, but we put a belt underneath the thread cap, a fabric belt, not steel, just a fabric belt. And that seemed to give it a bit more rigidity. It gave it a bit more steering response than the cross-ply tyre did. Okay, then of course the radial ply tyre came along. And at Olympic Tyres, that came along by mistake. And that's the truth. We were playing around. I was the development engineer at the time, or apprentice engineer at the time, and somebody decided, go away and build me a radial tyre. Yeah, okay, we'll do that. And we were making already at that stage a fabric belted radials, and that was that famous, probably best tire I've ever come across in my life. It was an ER70 14, cross-pipe belted. It was a radial, we used to call it the honeycomb pattern. It was on the GT Falcon, specifically, nearly exclusively until we developed another one for it. And the radial tire is a different animal. The same plies are used, so the material didn't change. It's the construction that changed. All of a sudden, those sharp angles disappeared. And again, if I remember my specification, the angle between plies was no more than 4 degrees. So instead of having plies that were going like across, you now have a radial just crossing each other at 4-degree angle. The tubeless liner stayed the same. And as I said, at first, we started making it with fabric. But all of a sudden, the steel belted radial took over. And to make the steel belted radial, then new technology had to be developed. You had to develop a calendar to actually make the steel cord. Now, this steel cord is not easy to make. 540 wires, individual wires, that run across this particular piece of equipment, that somehow we had to guide them and bring them into about a sheet about 1 meter wide and rubber coated on both sides, controlled humidity, controlled temperature, and wrapped in plastic, because the moment that stuff hit the air, it started blooming, and once it blooms, and if you remember the steel belted tires of the 80s, they would just blow the tread clean off. And the biggest enemy of this particular tire was water. So we had to make sure that all our factories were as dry as possible. I remember shutting the factory down when we had a deluge one day. Actually shut it down because of that, because there was that much moisture in the air, we could not make tires. So the steel belted radials, as I said, was made out of high tensile steel. At first they were just that, but then as time goes on, we realized that why threads were flying off is because rust started settling on the belt, and of course rust grows and it creates air, that gas blows and throws the thread off. So we started with the manufacturers, which I think it was in Geelong, we started actually covering or coating the steel belt with brass. And I tell you what, one strand of that stuff could pull a boat. Yep, they are that strong, it's not funny. Now the thing about it here is that these steel belts were, again, in this occasion, run at a very sharp angle. So you had the plies running diagonal, but the actual belt itself, to stop the thread squirming, right, were at a very sharp angle, 65 to 69 degrees. And on top of that, we also put a reinforcement strip. Now, some of it was a flat sheet, and sometimes we actually wrapped it with a small sheet. The radial tires have not changed much over the last 20 odd years. The only innovation in radial ply tires has been the introduction of Kevlar. And that came about with from an army perspective, where they wanted tires that were as resistant to bulletproof scenarios as possible. Here we made them for the Australian troops on their, I can't remember what was called, bush ranger machine, so the whole sideboard was actually Kevlar. But apart from that, not a great deal has changed. The big advantage is the comfort that the radial gives you, and the reduced heat resistance. With that, of course, you lower the rolling resistance, thus you get better fuel mileage out of it. The tread. So let's look at some components individually now. The tread. Now this is, back in the day, it was one compound, did everything badly, and that was it. With radial ply tires, there could be up to 6 different compounds to make a tread. you'll have the actual, what we used to call the cap, which is the part that actually touches the road. You had the base underneath that, and then you had the wings, and they could vary in different compounds altogether. To do that, you can see the machinery that is now available. That was not available when we had 3 separate extruders to make all the different bits, and literally have another machine that joined them together, which was a pain in the butt. But that's the sort of stuff that's being used today. So it's called a triple extruder. So the middle extruder is making the cap, the top extruder is making the base, and the bottom extruder is making the wings, and they come out of the die at the front, ready-made. One long continuous roll. As they come out, we immediately have to cull the chemical reaction. They come out of the extruder, bloody hot, that rubber. And so the first thing we need to do is actually cut that chemical reaction that's happening. So it goes into a chilled water tank that's probably 300 to 400 meters long. All the water is blown off it, top and bottom, rolled into big rolls and ready for the building machine. The sidewall, same scenario. It's the part that is probably the strongest part of rubber that we make in a tire, because it has to protect those plies and also maintain the air. It does a lot of work in, it's acting like a spring. The sidewall is your spring in the tire. And as a matter of fact, when I used to teach new apprentices of what tires are about, that's what I used to use. I used to use the example of a spring to explain to them how a sidewall actually functions. The sidewall tells you everything you need to know about that tire, and we will go through that individually as we go along. So a tire that must have load and pressure requirement, and that is without load index. We'll explain these a bit further. The speed symbol. Now the speed symbol is interesting. Up to 1985, there's only the highest speed symbol in Australia by new car manufacturers was H. H was 180 kilometers per hour maximum. Today, we're at V and Y's, 240, 250 kilometers per hour. So, if you have a car that's got a V-rated tire and you fit a H-rated tire on because of economics or whatever, or because you don't know better, and you have a car accident, your car is deemed illegal. Just because of the speed rating. Simple as that. So be careful with the speed rating. The manufacturing country is very important nowadays because they're coming from everywhere. Location of tread wear indicators, spot on. Tread wear indicators are not there to look pretty. They're there to tell you, hey, you need to change your tires. And if you're a person like me that you stop at a set of lights and look at what tires are on a car next to you, you'll be horrified at what's going on out there. Yeah. There are some countries that design tires, like especially in Europe, where there is snow, so there's a winter tire and a summer tire. We're lucky in Australia, we don't have to worry about that. All our tires are summer tires. The ECE approval, if it doesn't have ECE approval, that tire is not legal. And the most important for us, tube or tubeless, and the DOT marking, Department of Transport. If it doesn't have the Department of Transport, the tire came into Australia illegally. And you could be liable. So be a bit careful. The sidewall needs to be read and understood. Okay, some of the other components. The shafer and the cross-ply tire is the lining between the body and the bead. The bead is what keeps the tire on the rim. The shafer is what protects that bead wire and also transmits torque in the tire. So we spoke about, briefly about some, differences in the construction of tires. Now let's have a look at ply rating because they're quite important. Again, if your car manufacturing or OE manufacturer had a 4-ply rating tire, don't put a 2-ply in there. Make sure that you, at minimum, you stick with the original equipment requirement of the tire. So, as I said before, the days of counting plies is gone because, as I said before, one steel cord and it's equal to whatever the designer wants to make it. just by the way he changes them. What is tyre ply? We explained it already. They were cotton fibers, now they're nylon. There was an attempt to make it into rayon just after World War II, and that was a disaster because it used to change that much in the driving experience. It wasn't funny, so it was never used. Fast forward to today, and plies are manufactured with rubberized textile cords wrapped under the base of the tyre, which is different to what the cross plies used to be, where you actually have to manually turn up the plies, and that created all sorts of problems with air in the bead area. So the term ply rating now is indicated as the load range. How much load can that tire actually carry, and that is something we, all of us, I think sometimes forget when we're buying new tires. All right. So where do we find this information? So on the sidewall, you've got everything that you'll ever need. Well, let's start with some of the numbers there. P. It's very simple. Passenger. If it was light truck, it would be LT. Okay. 215 is the tread width, one end to the other, at the widest point. 215. 65 is the height of the sidewall. What that is basically saying is that the sidewall is 65% of the tread width in height. That's all that is, just 65%. R stands for radial, and here's the anomaly now. All of a sudden we go back to inches. So 15 is the tire diameter, 15-inch diameter. Here we go. 89 is the load index. You can't put a tire that's 85 legally. You can fit it, no problem, but you do that at your own peril. H is the speed rating. H is 180 kilometers per hour. If your new car is V and you put a H on it, it's illegal. Okay, so here's an example of the tire load and index chart. You can see there, 62, 265 kilograms. Take another one at random, 84, 500 kilograms. 105, 925 kilograms. Let me give you an example of this. When I was given the caravan industry to look after from tire and design perspective, I sat down with Jacob, and to my horror, I discovered that in the middle 80s, Jacob was still fitting 695/14 cross-ply tires on 5x14 Ford or GM pattern black wheels. When I asked Jacob to give me the load rating for the wheel, and together with ROH, because they're sitting on the meeting as well, to my horror, the loading on that wheel was 375 kilograms. The tire they were fitting on was at 375 kilograms. No wonder wheels were flying off caravans left, right, and center in the middle 80s. So what I did is I actually went down to ROH, and we together designed a wheel called the, what was it called again? Let me see, Ranger White, that carried 850 kilograms, certified at 850 kilograms. Therefore, we could then start fitting some real tires on the caravans. 185 light truck. They carried 850 kilograms. Everything nice, hunky-dory, and legal. Today, that is standard across the caravan industry, and you don't hear of wheels flying off anymore because they're carrying the right load and the right loading on both tire and wheel. Speed ratings. This is again crucial. Okay? M, 130 kilometers per hour. S, 180 kilometers per hour. H, wherever it is, 210, and so on. So when we're buying new tires, look after that. Make sure that it's okay. Quick example, and we'll wrap it up. If I want to increase the tread width without altering the tire diameter, here's a quick gauge. I have a 195/14 diameter tire, 644 millimeter diameter. That's what it is. And you can find the diameter of tires on a computer nowadays. Just go into a tire calculator and you can do this on computer, all of it. So I want to weigh the tire tread without changing the speedo or the rim. I want to stay with the same rim. So a quick way to do it is 195 becomes 205, so you go up in tire size. 75, you've got to come down. You reduce the 75 to 70 and stay with 14. Look where the diameter changes. 643. Beautiful. At 100 k's, you're actually doing 90. No. 95. Brilliant. You never get booked, will you? If you do it that way. However, what people do is, oh, I like the 235 better. Two things they're doing wrong. The 235 14, that will fit on the rim, no problem. But what are you going to do? You're going to stretch the crap out of that sidewall. It's going to be out here somewhere like that. And the sidewall is not going to do anything. It's not going to do what it's designed to do, and that's to flex. Okay? So, the second one, I want to change the 16-inch rims, but I don't want to change the diameter or the speed over. 195 becomes a 215 55 16. 643 again, legal, you can do it. No problem. And your speedo won't change. So when we're buying tires, guys, the other thing we need to do is make sure that our diameters are within 2% of the original tire that we have on, and our speed rating and our load rating is at minimum what the manufacturer has put on the placard, or better. So, that's the example I gave before. 980, 850, and leave it at that. Okay, that is all. Any questions?
Why is it still in inches? Why is the wheel diameter still in inches when everything else is?
Because wheel diameter is an issue, because if you change the wheel diameter, I mean, going from 14 to 16, is that what you're referring to?
No, you go from 15 inch to whatever it is in metric.
Exactly, but if you do that without checking the overall diameter of the tire, your speedo is going to be completely out of whack. And the other big problem is when people have what they call staggered wheels, so the back wheels are different to the front wheels. It absolutely plays havoc with your speedo and with the way the car performs, basically, because the cars, especially modern cars with computers, they're hunting. What speed is it doing?
I think he's trying to say is why it's still staying imperial compared to metric. Why are the tyres still?
Because the English are funny people, and they did not want to convert the 15-inch, because they know that, right? The Americans and the English, 15-inch. The French tried that, it didn't work. Michelin did that, it didn't work. Yeah. Sure.
Can you tell us anything about Formula One tires?
Yeah, racing slicks. Are they constructed the same way?
They are
only 3 millimeters.
irrespective of what the tire it is, the construction of a F1 or I worked on the when we got the contract back for the supercars. They're exactly the same. The only difference is the compounds are so much different, and the precision that goes into building those tires. I mean, each component is certified. So they put the first ply on, it's certified. They put the second ply on, it's certified. They check it for air leak. They do this, they do that. They're perfection impersonated, and they still blow off.
Quick question. What about the new Eco tyres they're saying that last?
The only difference with Eco tires is that what manufacturer does is tries and see, tire design is a compromise. It's a black art, it really is. What they're trying to do with e-tires is reduce the rolling resistance as possible. The offset then is longevity, so how long will the tire last, and road holding. That's the offset. So if you buy an e-tire, don't expect 60,000 kilometers out of it.
What should you get it from a tyre?
Well, that's a loaded question. I had tires that went 80,000 kilometers. I had others that went 36,000 kilometers. It all depends on what you want. If you want performance, don't expect more than 40. Anybody else? Yes, there are date codes. Unfortunately, all manufacturers are different. I personally don't believe that, you know, there is a longevity scenario with tires. I mean, some people say, oh, but the tire is 5 years old, I won't buy that. That's bull. You know, the tires are compounded to last a lot longer than that. I would say keep them out of the sun. That is a must. And the other one is don't put them on top of each other, because what's going to happen to the bottom tire? You're going to put a memory in it. The steel belts in a radial tire have got a memory. They really do have a memory. And if you flat spot them, they will never come back. They'll never recover. You can put as much air as you want. They will never, ever recover. All right? Okay, thanks guys. Appreciate it.